All right, welcome back to Mr. Powers Teaches Algebra. We are going to do some examples today of solving nonlinear systems of equations. A couple easy ones. For now, let's make this one short and sweet, and let's just do an example of a parabola with a line, right? We can see this guy is a quadratic. That would be a parabola when we graph it. This guy would be a line when we graph it. Okay, so let's solve this system of equations. So just as a quick review, a system, this is a system. It's multiple equations, and we want to find a solution that is a solution to both of them at the same time. That's going to be our solution. So to solve these, our deal is we want to get rid of one of the variables, get it down to something we're very comfortable with, and that is solving one equation with one unknown. And right away, I can already see, as it has been pointed out, they're both solved for y, so we can go ahead and set the right sides equal to each other. Or say substitute negative 3x minus 2 in for y in our top equation here. So let's do that. And what I'll get is, here, let me move that over. We'll get negative 3x minus 2 equals x squared minus 9x minus 9. All right. And then I want to solve it. Now it's a simple quadratic equation. And now we'll just use our normal steps, our normal philosophy or strategies for solving quadratics. That is set one side equal to 0. And try to factor if we can factor, because factoring's easier than sticking everything in a calculator. Right? I don't know. It's more fun. Okay, so I'm going to add 2 to both sides. You know what? I'm going to add 2 and I'm going to add 3x to both sides, because really I'm just adding 3x plus 2 to both sides. So I'm okay there. We can do that in one go. That's going to give us 0 plus 0, which is 0 on the left. And on the right, we're going to get x squared minus 6x minus 7. You'll love to see it. That's a super easy equation to factor. And so we're going to use our normal strategies for factoring. I like guess and check. Multiples of 7. Well, there's only 2 factors of 7, and that's 1 and 7. So we're going to have an x minus 1 and an x minus 7. But one of them needs to be positive since we have a negative here. But we have a negative 6 here. So the negative 7 needs to be negative. The 1 needs to be positive. And then we're going to have negative 1 times 7 is negative 7. So that's going to be good. And then that middle term is going to be x and negative 7x. That'll get us negative 6x. So we're good. Cool. There it is. We got 0. Since we factored this, we know that 0 times something equals 0. So we know that set this equal to 0 was one solution. So in other words, x equals negative 1 will be one solution, possibly. And over here, x equals 7. And as we've seen before, when we have a parabola and a line, they could possibly cross in 2 places. And that's what it's looking like here. So let's go ahead and, well, it's definitely looking like that, because I can plug negative 1 and 7 in for x in either one of these very easily and get solutions. I'm going to pick the easiest one here to get my y's, because we need y's to match up with each of these, right? So if x equals negative 1, that implies that y equals, I'm going to do this one, negative 3 times negative 1 minus 2. And I'm using this one because it's an easier equation. I could plug it in either one. The negative 1 for x, I could plug in to the quadratic or the linear equation. It doesn't matter. The linear is easier, so I'm just going to use that one. It shouldn't matter, assuming I didn't make a mistake. If you want to be extra sure, plug it in both. Make sure we get the same answer. So anyway, simplifying this down, we get negative 3 times negative 1 is 3 minus 2. So we're going to get y equals 1 when x equals negative 1. So that is giving us a solution of negative 1, comma 1. Great. One more. Let's say when x equals 7, what do we get? If x equals 7, that implies y is going to equal negative 3 times 7 minus 2. And so we're going to get negative 21 minus 2 right there. And last but not least, negative 21 minus 2 is negative 23, I think. So when x equals 7, y equals negative 23, that gives us a solution here, 7 comma negative 23. And we can plug those. And then, well, that's it. We're done. We got our two solutions here. I'll highlight them. Bam. And bam. And if you want to check your solutions, see if they are solutions with technology, there's a couple ways to do it. Graphing calculator is kind of a nice way with something simple like this. All right. So let's go ahead and do that. Let's take a look at our graphing calculator. Hold on here. Bam. And let's do that. We had two equations here. We'll just plug those in. All right. Of course, I'm using geogebra.org/calculator. And I just finished just typing them in exactly the way I see them into each of these input boxes. Hit enter. And it labeled them F and G. That's fine, whatever. And it automatically graphs them. And I can just easily go here, show me one intersection at negative 1, 1. Okay, and was that an answer I got? Yes. And then we should have another intersection. We can zoom out really easily. I have another one here, 7, negative 23. Yes, that is what I had. So our solutions look great. Super easy. Until next time, enjoy doing math.